You have been lied to. The Erie Canal, stretching 363 miles across the state of New York, was allegedly constructed between 1817 and 1825 by manual labor. Shovels, pickaxes, wheelbarrows, 10,000 men, most of them Irish and German immigrants, supposedly moved enough earth to fill a structure the size of the Great Pyramid of Giza. Not once, but 16 times over. The official narrative tells us these men, with no mechanical assistance, carved through rock, redirected rivers, built 83 locks, and excavated approximately 42 million cubic yards of material in just 8 years. Let us be clear about what 42 million cubic yards means. If you were to load this earth into modern dump trucks, each carrying 10 cubic yards, you would need 4.2 million truckloads. Lined up end to end, those trucks would circle the earth at the equator more than twice. And we are expected to believe that men with shovels accomplished this feat in the early 19th century, during an era when the United States had barely recovered from a second war with Britain, when its population was scattered and its industrial base virtually non-existent. The math doesn't just fail, it insults the intelligence of anyone who has ever held a tool. Consider the timeline. 8 years. 2,920 days. To move 42 million cubic yards in that period requires the excavation of 14,384 cubic yards per day. Every single day, without rest, without winter, freezes halting progress, without equipment failure, because there was no equipment to fail. Now divide that daily quota by the alleged workforce of 10,000 men. Each laborer would need to excavate 1.4 cubic yards per day. That might sound almost reasonable until you understand what a cubic yard of compacted earth actually represents. It is not loose topsoil. The Erie Canal cut through clay, through shale, through limestone bedrock in several sections. A cubic yard of this material weighs between 2,000 and 3,000 pounds. One man, using a shovel and pickaxe, moving 1.4 cubic yards of compacted clay per day, means he is lifting and relocating nearly 4,000 pounds of earth, scooping it, hauling it, dumping it, in addition to the initial breaking of the ground. This is the output expected of a mining operation with hydraulic machinery, not a construction site populated by farmers turned laborers working for 80 cents a day. But let us go deeper. Let us examine not just the digging, but the infrastructure required to sustain such an operation. 10,000 men working continuously for 8 years. Where did they sleep? The canal route passed through wilderness, through forests and swamps where no towns existed. You cannot house 10,000 men in tents through a New York winter when temperatures plunge below freezing for months. Barracks would have been required. Heated barracks. To construct housing for 10,000 workers, you would need approximately 2 million board feet of lumber, assuming a minimum of 200 square feet per man in cramped utilitarian structures. Sawmills would need to run at full capacity for months simply to supply the wood. Yet there is no record of a massive lumber operation preceding the canal project. No forests were documented as being cleared specifically for worker housing. The housing, like so much of this story, exists only in abstraction. And what did these men eat? A laborer performing the kind of brutal physical work described would require a minimum of 4,000 calories per day to avoid starvation and maintain muscle mass. 10,000 men consuming 4,000 calories each equals 40 million calories per day. Assume a simple diet: bread, salted pork, beans, and occasional vegetables. Feeding this workforce for 8 years would require approximately 116 million pounds of food. This is not a number pulled from speculation. This is the minimum nutritional baseline for human survival under extreme labor conditions. Where are the supply trains? Where are the granaries, the smokehouses, the bakeries? The Erie Canal was constructed before the expansion of American railways. Overland transport meant wagons pulled by horses or oxen on roads that were little more than mud tracks. To deliver 116 million pounds of food over 8 years across hundreds of miles of undeveloped territory would require a logistics operation rivaling a military campaign. There is no evidence this supply chain ever existed. Consider the horses and oxen themselves. These animals would have been essential not just for transport, but for hauling the excavated earth away from the dig site. A single horse can pull approximately 1 ton in a wagon under ideal conditions. On rough terrain, through mud, in winter, that capacity drops to half. To move 14,000 cubic yards per day, assuming an average weight of 2,500 pounds per cubic yard, you're moving 17,500 tons of material daily. That requires 17,500 horse trips per day, or a permanent stable of at least 2,000 horses working in rotations, accounting for rest, feeding, and the reality that horses cannot work 24 hours continuously. 2,000 horses consume approximately 40,000 pounds of hay and grain per day. Over 8 years, that is 116 million pounds of animal feed in addition to the human food requirements. Where are the pastures? Where are the hay barns? Where are the veterinary stations to treat injured or sick animals? A workforce of this scale requires a support infrastructure that would rival a small city. Yet no archaeological evidence of such settlements exists along the canal route. Then there is the question of the tools themselves. Shovels wear out. A shovel used to break compacted clay, and stone will lose its edge, crack its handle, bend its blade. Under the conditions described, a single shovel might last 2 months of hard use before becoming ineffective. 10,000 men working for 8 years, each requiring multiple shovels over the course of the project, means the consumption of approximately 480,000 shovels. Each one had to be forged, fitted with a wooden handle, and transported to the worksite. The same applies to pickaxes, wheelbarrows, ropes, and every other piece of equipment. There would need to be a constant supply line of replacement tools flowing into the canal zone. A single blacksmith, working full-time, can produce perhaps 3 shovels per day. To manufacture 480,000 shovels over 8 years requires approximately 164 shovels per day, necessitating a workforce of at least 55 blacksmiths dedicated solely to shovel production. Then you need the iron. Each shovel requires approximately 5 pounds of iron. 480,000 shovels means 2.4 million pounds of raw iron, which must be mined, smelted, and transported. In 1817, American iron production was minuscule compared to European output. The entire domestic iron industry would have needed to dedicate a substantial portion of its capacity solely to supplying tools for one construction project. Again, no records exist of such an industrial output. The blacksmiths, the foundries, the wagon networks required to sustain this operation are missing from history. They are ghosts. Let us address the locks. 83 locks, each constructed from hand-cut limestone blocks. A single lock required thousands of precisely shaped stones, each weighing hundreds of pounds, fitted together without mortar in many cases, using a technique that demanded near-perfect dimensional accuracy. Cutting one limestone block by hand, using hammer and chisel, takes a skilled mason approximately 8 hours. Multiply this by the thousands of blocks per lock, then multiply again by 83 locks. The man-hours required exceed the available labor pool, even if every worker had been a trained stonemason, which they were not. Most were common laborers with no experience in precision stonework. Yet the locks were completed on schedule, with tolerances tight enough that water did not leak through the seams. This level of craftsmanship does not emerge from untrained hands, no matter how many of those hands you put to work. Examine the stone itself. Limestone is not uniform. It contains layers, fissures, variations in density. A mason must understand the grain of the stone, how it will split, where it is weak, where it is strong. This knowledge comes from years of experience, yet we are told that immigrant laborers, many of whom had never worked with stone before arriving in America, achieved master-level results within months. The blocks fit together with joints so tight that a knife blade cannot slide between them in many sections. This is not amateur work. This is the output of a guild system, of generational knowledge passed from master to apprentice. It does not appear spontaneously in an untrained workforce, no matter how motivated or how numerous. There is another element that deserves scrutiny: the engineering surveys. Before a single shovel touched earth, the entire route had to be surveyed, graded, and planned. This was not a straight line. The canal had to navigate changes in elevation totaling approximately 565 feet from the Hudson River to Lake Erie. It required aqueducts to cross rivers, embankments to traverse valleys, and a precise gradient to ensure water flow without excessive current. Surveying instruments in 1817 were rudimentary: transits, chains, and levels. To survey 363 miles of wilderness terrain with the accuracy required for a canal would take a team of experienced surveyors, years of continuous work. Who were these men? The United States had virtually no civil engineering tradition at the time. The few trained engineers in the country were concentrated in military fortifications or nascent urban projects. Yet we are told that the Erie Canal survey was completed rapidly and without error, because the canal was dug along the plotted route, and it functioned. This implies a level of surveying expertise that should not have existed in early American society. The most famous name associated with the canal's engineering is Benjamin Wright, often called the father of American civil engineering. But examine his background. Wright was a lawyer and a judge, not an engineer. He had no formal training in hydraulics, no education in structural mechanics, no apprenticeship under experienced canal builders. His qualification was that he had done some basic land surveying for property disputes. Yet he was appointed chief engineer of the most ambitious infrastructure project ever attempted in North America. This is akin to hiring a real estate agent to design a nuclear power plant. The disconnect between credentials and responsibility is staggering, unless Wright was not designing anything, unless he was simply overseeing the restoration of something already there, following plans and specifications that predated his involvement. Now consider the context. 1817. The Industrial Revolution had begun in Britain, but it had barely touched American shores. There were no steam-powered excavators, no railroads to transport materials. The first commercial railroad in the United States would not be operational for another 3 decades. Mechanization was a fantasy for most Americans, who still lived in an agrarian economy where the vast majority of labor was performed by human muscle or animal power. Yet somehow, in this pre-industrial society, a project was undertaken that required industrial-scale logistics, precision engineering, and continuous material throughput. The official story asks us to believe that this was accomplished through sheer determination and manual effort. It asks us to ignore the laws of thermodynamics, the limits of human endurance, and the basic requirements of organized labor. There is a simpler explanation. We did not build the Erie Canal. We found it. Or more precisely, we restored it. The infrastructure was already there, buried under centuries of sediment, overgrown with vegetation, filled with debris. What the crews of 1817 did was clear it out, repair the locks, and rebrand it as an American achievement. This is not speculation rooted in fantasy. This is logistical realism. When the math does not support the narrative must be questioned. The Erie Canal exhibits characteristics inconsistent with early 19th century construction: the precision of the locks, the uniformity of the channel depth, the strategic placement along a route that maximizes geographical advantage while minimizing engineering obstacles. These are not the hallmarks of trial and error construction by untrained laborers. These are the signs of a pre-existing design, executed by a civilization with advanced knowledge of hydrology and civil engineering. Look at the maps. Before the canal was officially begun, there are references in old land surveys to ancient watercourses and dry channels running through central New York. These were dismissed as natural features, remnants of glacial melt. But the alignment is too precise. Natural watercourses meander. They follow the path of least resistance in chaotic patterns. The Erie Canal's route is geometrically efficient, cutting through obstacles that a natural river would avoid. It behaves like an artificial structure, which it is, but an artificial structure far older than 1817. The stones used in the locks show weathering patterns inconsistent with 200 years of exposure. Deep erosion, molecular breakdown of the limestone surface, types of lichen growth that require centuries to establish. These details are visible to anyone who examines the oldest sections with a trained eye, yet they are never discussed in official historical accounts. Then there is the matter of precedent. The United States had never built a canal of this scale before. There were small canals, local projects spanning a few miles, used primarily for mill operations, but nothing approaching the complexity or length of the Erie. To go from constructing 10-mile ditches to engineering a 363-mile waterway with 83 locks is not an incremental step. It is a civilizational leap. It would be like going from building wooden carts to assembling a suspension bridge. The knowledge gap is too vast. The learning curve is too steep. Yet there are no records of catastrophic failures, of sections that collapsed and had to be rebuilt, of trial and error experimentation that one would expect from a society attempting something for the first time. The canal worked. It worked immediately. Water flowed, boats navigated, commerce moved. This does not happen when you are inventing the process as you go. Compare this to other first attempts in engineering history. The early railroads were plagued with derailments, boiler explosions, track failures. The first iron bridges saw numerous collapses before engineers understood load distribution and material fatigue. The first skyscrapers required constant revision and reinforcement as builders discovered the limits of their materials. Every genuinely new technology goes through a phase of spectacular failures. It is how engineering knowledge accumulates: trial, error, catastrophe, revision, improvement. The Erie Canal has no such history. It opened, it functioned, it succeeded. This is not the pattern of innovation. This is the pattern of replication. Someone knew how to build this because someone had built it before. We must also ask what the canal was originally designed to do. The official explanation is economic, to connect the Great Lakes to the Atlantic Ocean, facilitating trade and settlement. But consider the engineering. The canal is 40 feet wide and 4 feet deep for most of its length. These are not arbitrary dimensions. 40 feet is wide enough to allow two boats to pass each other with minimal clearance. 4 feet is deep enough to support vessels with a draft of 3 feet while maintaining clearance from the bottom. These are optimized parameters. They suggest a design intent focused on efficiency and standardization. But efficiency for what? 19th century cargo barges were not standardized. They varied wildly in size and draft. Yet the canal dimensions fit them perfectly, as if the boats were built to match the canal, rather than the canal being sized to accommodate the boats. This implies the canal predates the boats, that it was constructed with a specific type of vessel in mind, a vessel we no longer recognize. There are other anomalies. Certain sections of the canal pass through areas where the geological substrate should have made excavation impossible with hand tools. Solid bedrock formations that would require blasting. Yet the historical record mentions no extensive use of explosives. Gunpowder was expensive and difficult to transport in large quantities. Blasting operations required trained personnel to drill holes, pack charges, and execute controlled detonations. A workforce of immigrant laborers would not possess this expertise. Yet the canal passes through these rock formations as if the stone were not there, as if the channel had been cut by something other than human hands with iron tools. Modern geologists examining these sections have noted cut marks that appear inconsistent with the percussion patterns of hand chisels. The cuts are too clean, too uniform, suggesting a technology we do not associate with the early 19th century. Let us turn to the beneficiaries. Who profited from the canal's construction? The state of New York financed the project through bonds, betting that toll revenues would repay the debt. And they did. The canal was a financial success, generating enormous wealth for New York City and establishing it as the dominant commercial hub of the United States. But here is the question. How did the planners know it would succeed? There was no guarantee that settlers would move west, that trade would flow, that the canal would be used. Infrastructure projects are gambles. They require decades to generate returns. Many fail completely. Yet the investors showed remarkable confidence. They poured millions of dollars into a project with no comparable precedent, in a nation that had never successfully completed anything similar. Unless they knew, unless they understood that the infrastructure was already proven, that it had worked before, that they were simply reactivating an ancient trade route rather than gambling on an untested experiment. The confidence with which the project was undertaken suggests prior knowledge. It suggests that someone, somewhere, had access to information about the canal's original purpose and capacity. Look at the trajectory of American development after the canal's completion. It accelerates. Railroads spread rapidly. Industrial capacity explodes. Cities grow at unprecedented rates. It is as if the canal unlocked something, not just economically, but technologically, as if studying its construction, reverse engineering its methods, provided insights that propelled the nation forward. This pattern repeats throughout history. Civilizations do not advance in smooth, linear progressions. They leap. They stagnate for centuries, then suddenly achieve breakthroughs that seem to come from nowhere. The most rational explanation is that these breakthroughs are not inventions. They are rediscoveries. We find the tools left by the previous tenants, and we learn to use them. Consider the possibility that North America was not an untouched wilderness when Europeans arrived, that the forests, the prairies, the landscapes described as pristine were actually the remnants of a managed environment, abandoned and overgrown. The earthworks found throughout the Ohio Valley and the Midwest, the mounds, the geometric enclosures. Officially, these are attributed to Native American cultures, and certainly indigenous peoples built many of them. But the scale of some structures defies the resources available to semi-nomadic tribes. Cahokia, at its peak, was larger than London. Its earthworks required millions of cubic feet of soil to be moved and shaped. The same logistical problems we see with the Erie Canal apply here. The same missing infrastructure, the same impossible timelines, unless the timeline is wrong, unless these structures are far older than we have been told, built by a different culture entirely, and later inhabited by the peoples we call Native Americans. The Erie Canal may have been one piece of a much larger system, a network of waterways, roads, and energy conduits that once spanned the continent. We see traces of this network in the old maps, the ones drawn before official surveys, the ones marked with symbols and notations that no longer make sense. Straight lines connecting distant points, channels where no rivers run, geometric patterns imposed on the landscape. These are not decorative. They are functional. They describe a world we have forgotten how to see. A world where the land was shaped, where water was directed, where energy flowed through conduits we no longer recognize because we lack the framework to interpret them. The stones do not lie. The canal is there. It exists. The earth was moved. The locks were built. These are facts. The only question is when and by whom. The official narrative provides an answer, but the answer does not withstand scrutiny. The numbers collapse. The logistics evaporate. We are left with a structure that should not exist, built by a society that lacked the means to build it, in a time frame that defies physical possibility. So we adjust our understanding. We accept that history is not what we were taught. We recognize that the 19th century was not an age of construction, but an age of restoration. We found the bones of a dead civilization and we wore its skin. Walk through your own city. Look at the buildings downtown, the ones with windows half buried below street level, basement windows that open onto sidewalks. Why are they there? The standard explanation is that street levels rose over time as roads were paved and repaved. But how much paving does it take to bury an entire floor? 3 feet? 5 feet? In some cities, the burial goes deeper. 10 feet. 15. Entire ground floors swallowed by sediment and fill. The official story treats this as an unremarkable side effect of urban development. But consider the alternative. The streets did not rise. The city sank. Or more accurately, the city was already partially buried when modern inhabitants arrived. We excavated what we could, repurposed what remained, and built on top of the ruins. The buried windows are not evidence of progress. They are evidence of forgetting. The Erie Canal fits this pattern. It was not dug. It was unearthed. The labor crews of 1817 were not constructing a new waterway. They were clearing an old one, removing sediment, repairing locks, restoring functionality to a system that had fallen into decay. This explains the impossible timeline. This explains the missing infrastructure. This explains the precision and sophistication of the engineering. We did not build it because we did not need to. It was already there, waiting beneath the soil, waiting for someone to rediscover it and claim it as their own. History is a set of lies agreed upon, but the stones do not lie. They wait. They endure. And they ask a question that no official narrative can answer. If we did not build this, then who did? What civilization possessed the knowledge, the resources, the will to reshape an entire continent? And what happened to them? Where did they go? Did they leave, or did they simply fade, their work slowly consumed by time and earth until only fragments remained, fragments we mistake for our own achievements? Look at the canal. Look at the locks. Look at the precision. Then ask yourself, do you really believe 10,000 men with shovels did this in 8 years? Or have you been told a story designed to make you forget what you are actually seeing? The world is not what they taught you. The past is not a simple progression from primitive to advanced. It is a cycle. Civilizations rise, achieve heights we cannot imagine, then collapse and are forgotten. We scavenge their remains, reverse engineer their tools, and convince ourselves we invented them. The Erie Canal is not an achievement of American ingenuity. It is a monument to amnesia. It is proof that we have forgotten who we are and where we came from. And until we remember, we will continue to live in the shadow of giants, calling their works our own, never understanding what we have truly inherited.